Okay, welcome back. Guys, I want to talk about mean value theorem for definite integrals. So let's do a little refresher on the mean value theorem. The mean value theorem says that if I've got some function, y equals f of x, and I've got an interval between a and b, and I've got f of a and f of b, if I choose some value y sub 0 that is in the interval f of a to f of b, in other words, f of a less or equal to y sub 0 less or equal to f sub b, then there must exist a value of c such that y sub 0 is equal to f of c, and c has to be in the interval ab. Well, the only difference between the mean value theorem that we discussed for values and the mean value theorem for definite integrals is that there isn't really a difference, except that we're just going to drag in the average value. I'm not going to go through the whole process of how we got there, but here's the mean value theorem for definite integrals. So MVT for definite integrals for DI. So f is continuous. Now remember, that's really important. It's continuous on the interval AB. Then the average value of f, well, the average value of f is our y sub 0 because it is some value of the function that's in the interval. The average value of f must occur at some c in AB. Now, if I write that exactly like I wrote the previous one, that means that there is some f of c, my average value, which is equal to 1 over b minus a times the integral from a to b of f of x dx, where c is in the interval ab. So, in other words, all we're doing is extending the idea that my average value must be between my high and my low values. And so therefore, there must be an x value in that interval that makes it true. So how do I do problems like this? Well, first thing I do is I have to say continuous. I have to state that explicitly. The function is continuous, therefore, and then I write this equation down and say, look at that, mean value theorem for definite integrals says this must be true. And then I can find the value of c that makes it true. All right, let's do a quick exploration. We are going to look at a circle. The circle has radius r. And what we want to do is we want to find the average perpendicular chord length on the interval negative r to r. I should probably clarify it. When I say perpendicular, I mean perpendicular to the x-axis. So there's my chord. It is perpendicular to the x-axis, and I want to find the average chord length on this circle. So let's do a little exploration. Here we go. Thing one, I notice that I have a right triangle here, and I'll go ahead and draw the right triangle down here. It has a radius, a hypotenuse of r. If I choose some value of x at which this chord occurs, then that means that this length is x. And I'm going to call this c for the purposes of argument, or for the purposes of ease of calculation. You'll notice that it's half the chord length. C is half of a chord length. And so we'll be multiplying by 2 at the end to get the actual chord lengths. Don't let that confuse you. All right, what do we know? Thing one, x squared plus c squared is equal to r squared, which means that the half chord length is equal to the square root of r squared minus x squared. So that means that the chord length is 2 times the square root of r squared minus x squared. And we want the average value. So we know that there's some average value c, which is 1 over b minus a times the integral from negative r to r of 2 root r squared minus x squared dx. So just so I don't want to gloss over this, this is 1 over b minus a times the integral from a to b of my function, which is chord length, dx. So let's think about what we know. The integral from negative r to r of these chords, r squared minus x squared dx, is the area of this circle, which is 2 pi r. Which means that my average value of a chord occurs at 1 over 2r times, wait, did I really just say 2 pi r? That's super awkward. Yeah. You're thinking, what on earth is this guy talking about? Yeah, pi r squared, area of a circle. Clearly, I could say I was waiting to see if you would catch it, but actually, no, I just made a weird mistake. The average value occurs at 1 over 2r, 1 over b minus a, times the area of this shape, which is pi r squared. The average value will occur at pi over 2r. And then the question is, does this actually fall inside the circle? Well, pi over 2, let's see, the chord length, that's a more complicated calculation than I really feel like doing. The length of the chord is pi over 2r, so we're talking about the length of this chord right here. Where does it occur? We could do the calculation, or we could just say that by the mean value theorem for definite, by the mean value theorem for definite integrals, because this is a continuous function, it must, the average value of c must occur in the interval negative r to r. The value itself is equal to pi over 2r. Okay. Hope that helps. Sorry, I want to make sure I'm not missing anything. I threw myself quite badly by writing 2 pi r there, and I feel like I never recovered. But hey, there you go.